Okay, we're now recording to the cloud. We have some new people today, too.
And did I turn off my sharing, or is it still there?
It's turned off.
Okay. Well, we should start. It's August 11th, 2020, and this is Tangerine SDR development meeting with members from both HamSci and Tangerine SDR. My name is Dave, KV0S, and this week I've been doing some a little bit of radio work, making some shop cables, and then I got an amp. Let's see if Dave's here. I got an amp from Bulgaria, active listening amp, and so I've been playing with that, and I built a loop antenna, so that I'm trying to see if I can make any progress with that. So that was my experimentation this week. Next is Nathaniel.
Thank you very
W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Things are going fine here. I got my career proposal submitted today, so that's all done and in the pipeline.
Good.
Yes, there's a lot of work. And let's see, I've been chasing around data for different things, trying to do some Whisper RBN visualizations, and I'm also trying to get, I just connected up a red Pitaya to my network again. It was in the box for a while, but I've got connected. I'm going to try to get a new radio running on my Linux box between tonight and tomorrow so that maybe I can help troubleshoot or follow along with what Dev is doing a little bit on his Edis. Oh, and we had the QSO Today Expo on Sunday. And so Phil, Erickson, Christina, and I presented at that. And I think we got some good feedback from it. And I think we have about 20 new members on the HamSci list. And I promoted the Tapper Digital Communications Conference. And we have at least two new people who will introduce themselves shortly. And they are interested in this project as well. Okay, W2NF, back to net.
Very good. And I was looking around. I didn't see your talk, but I was trying to see some of them. And I did spend a little time in around family stuff. Next on the list, we have Dan in for XWE. And Dan has a wonderful little script that'll help you get LinHPSDR installed. Nathaniel.
That might be good to try.
Hello, everyone. Yeah, I've spent a little bit of time working on scripts this week, not a lot, and I have one. My GNU radio script, for some reason, is broken, and I haven't quite figured out why. It worked for about a month.
Hey, Dan, your audio is real low. Maybe move the mic closer. It looks like it's kind of.
How about now?
It's a little better.
Yeah.
Yeah, I've got the mic turned up all the way, and I've got it positioned correctly, so not sure what the issue is.
Well, that's a little better. It was real weak before. It's still weak.
Okay.
Understandable. Go ahead.
All right, thanks for letting me know. I always hate to have my lips moving and nothing coming out. Okay. Anyway, the one thing I did do last week is get started on my Nexus DRX interface project. As I mentioned a little bit last week, I think. It is sort of a signal link that is attached to a Raspberry Pi. And it uses the Pi as the terminal. And I'm thinking I can run Pi HPSDR and possibly some other digital modes, WSJTX and maybe FLDigi stuff, and use it as a kind of a self-contained digital unit for a Go box. That's the end game, is to put together a Go box. I have just about everything I need in order to do that, except for a reliable way of interfacing to the digital world. Anyway, that's about it from here. Back to you, Dave.
Fine business, Dan. Next on the list, we have Mike. AA8K. Go ahead, Mike.
Greetings to everyone on the conference. Back to you, Dave.
Fine business. And we thank Mike for dealing with the recordings and posting them. Next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I have been talking to Bill Wiles, who has been giving me some great feedback on this VLF module project. And there were two issues that I wanted to bring to the table if there's room for general discussion later on. Other than that, I've been studying for my general, and that's pretty much it. Back to the net.
Well, fine business and good luck on your general. Next on the list is Gary, AF8A. Welcome back, Gary.
Yeah, good evening, everyone. No comments, just a question for Scotty when it gets to be his turn. Scotty, you mentioned last week about making the, I guess would be the current schematic available. I'm not sure where we'd see that. And I was also curious as to how that schematic relates to the prototype boards you were talking about manufacturing last week. That's it, back to net.
I think I can answer some of that. We have a section on the TangerineSDR.com website, and there's documents for the project, which are PDF files for each of the submodules. And I think we posted that schematic in that folder. So you can look for it. And if you have trouble finding it, we can help you again. Next on the list, we have Dev. Go ahead, Dev.
It's me?
Yes.
Yes. Thank you so much, Dave. So we have been continuing to try to work through our ETOS N200 installation at the University of Scranton Greenhouse, Loyola Science Building. So now we're using GNU Radio Companion flow graph to get the data from the ETOS N200. And now we are at the stage of trying to find ways to analyze those data so that we could look for signals that we're hoping to receive. Essentially, we're aiming to use digital DRF to analyze the data. So that's the agenda that I am looking forward to talk to in my next meeting with Nathaniel. Thank you.
Okay. Well, fine business. And next on the list, we have Jim Secan. Welcome. Go ahead.
Sure. Okay, that's better. Again, lips moving, nothing coming out.
It's working.
I've been sort of lurking on watching the emails go by on the group. My background is ionospheric physics, specifically ionospheric scintillation and the impact on ground to space, space to ground propagation channel. And what interested me in this particular program, HAMSCI in general and this program in particular, was when discussion went around to the LWA antenna. I'm currently working with a fellow, Dr. Joseph Helmbolt at NRL, and he's been working with the very large array folks out in New Mexico, making measurements that I'm starting to use for my scintillation work. But he's also come up with a smaller system that he's calling DLITE, and let's see if I can find what that means here. I'm afraid not, but anyway, it's supposed to be a light version of what he was doing with VLA, using the LWA antennas to make observations from radio stars, Cassiopeia A, Cygnus A, and those are the two I remember, but making scintillation observations at mid-latitudes using the radio stars. And this is a good thing to do because the radio stars are emitting down in the HF bands, 3 megahertz, and that's the frequency range you really need to be down to in order to really be able to observe mid-latitude scintillation. If you're looking at the typical satellite VHF signals in the 100 plus megahertz range, scintillation is down below the noise floor quite often. So the current scintillation model that we have, I'm afraid, is basically a model of VHF satellite noise floor at mid-latitudes rather than mid-latitude scintillation. So that's the backdrop. Now, what we were thinking, Joe and I talked about this, is that maybe this is something that could be done with the Tangerine SDR using one of these LDW type antennas that you're working on. And maybe we could set up a couple of these to make this sort of observation. I would love it to have more data. The model that I have is built on a climatology, and 2 or 3 data points do not a climatology make. So, more data is better, no matter how much more. So I was hoping Joe would be here. I'm an ionospheric person. I know enough about radio to be dangerous. That's about it. So I can't answer radio questions, but essentially that's the thing. If I can get, for my needs, if all I get out of it is a time series of the intensity of the signal from one of these very bright radio stars as a function of time, data rate of about a hertz, that's great. That will meet my need. If we can do more, which Joe's D-Light setup, he actually uses that to do sky images using various types of mathematical magic. And that requires setting up multiple antennas and being able to do very precise measurements, very precisely timed measurements between the antennas in order to create these maps. I don't think it's outside of the range of this project, but it would certainly be something that maybe a grad student could pick up and do some interesting work with. So again, I wish Joe was here. He said he might be able to make it tonight, but I don't see him. We should definitely try and get him here to talk to you folks at some point. But it sounded like an interesting thing to bring to look and see if this technology could actually do it. If it can't,
Very good.
worth a try.
Looks like you're in the right place. I think a lot of people would be interested in what you want to do. So just welcome.
Thank you very much. I've always been interested the times I've sat in on these sessions.
Yep, very good. Next on the list is we have Mohammed. Go ahead, Mohammed.
All right. Hello, everyone. My name is Mohammed, and currently I'm Assistant Professor of Physics and Electrical Engineering at the University of Scranton. And I do research in the RF and microwave component design, and especially in L and S band. So 1 to 4 gigahertz mostly. And I conduct research, and the motivation is mainly to write, journal papers, and so the reason for being interested in ham radio community is to use my knowledge to design something that can be used in the field, because you are the people who use these components in the field. So far my focus has been publishing, and so I thought that maybe I will get some space here, and I will also get to know how some of these components that I design here can be used in the field. And one more thing that I'm interested in knowing is that how big is this market, how often, for example, the ham radio community would be buying these modules like power amplifiers or the RF filters and those kind of things.
Well, I'm going to let Scotty, our engineering board maker, talk about that, because he's done some of that in the past. But what we're doing is doing something that's out of the norm for many ham radio operators, because we're trying to listen to things that are not just people talking to each other completely, although that's completely possible with this equipment. So anyway, we'll go on down through the list and introduce everybody, and then we'll have some open discussion. So next on the list welcome. And next on the list, we have Elizabeth. Go ahead, Elizabeth.
No
Are
audio.
you there?
No audio.
Well, we'll let Elizabeth figure it out. And next will be Bill, AB4EJ. Go ahead, Bill.
Hey, thanks, Dave. Good evening to you. Good evening to the net. Been working on several things. As you might recall, last week I was fighting a problem where the Tangerine localhost would crash after 6 to 8 hours for unknown reasons. I think I found that because I was able to run it for 24 hours, collecting data on the ring buffer and also doing FT8 analysis at the same time, which doesn't put as much of a load on the system as what I expected. We're seeing CPU utilization of less than 20% while doing all that, which is good on the Odroid N2. So that makes me feel hopeful we can put quite a bit more heavy load on this. You start running into contention on moving data around on the network before you start overloading the processor. At least that's been what I've seen so far. So what I've been working on lately is adding multi-channel support to the local host, because what I feel like we need to do is I need to be able to run one channel that's a ring buffer with a bunch of sub-channels on it. That's our Vita T, where the interleaved IQ data from the different sub-channels, and then run 8 FT8 channels, up to 8. And those will be Vita compliant, so that each one of them is a separate stream, but all that is runs as a single channel with, well, it's defined as a single channel, but it's 8 separate streams. I haven't figured out what to do on Whisper yet. So keeping track of all the different ports you have to deal with to manage multiple streams and multiple channels running at the same time is very tricky. I'm struggling with that quite a bit, but we'll get it figured out. So I did have one or two edge cases that I ran into that I'm going to bring up tonight during general discussion that we'll need to get some opinions from Scotty on. So back to net.
Very good. Elizabeth, are you still there? I'm not hearing any audio. Well, keep working on it. We'll come back to you. Tom McDermott, N5EG. Go ahead.
Oh, good evening, Dave, and good evening to everyone on the group. Not too much activity on the project this week. I took a look at Scotty's schematic, kind of scratched my head a little bit, and I think it looks like Scotty got a couple of comments, and so that's good. The review is helpful, and a couple of emails with Deb. I think Deb's gotten up and running on GRC now, so things look good. Back to the group.
Fine business. Elizabeth, are you there? Okay. Next on the list is Scotty. WA2DFI. Go ahead, Scotty.
Okay, can you hear me okay?
Yes, just fine.
Okay, well, thanks, Dave. Thanks for running the show as usual. So you got a good crowd, some new people. Welcome to everyone, the new people, and glad to have you. Couple things. See, the MagnetoPie hat is out. The schematic is up for review, and for let's see, was it Gary? I think asked about it. I put the link up there to the schematic, and so hopefully you can see that. I did get some good comments on it. A few things. I think one thing that Dave Witten discovered on the enable input. I think I don't know if it was Tom that pointed that out, that the enable input has to be delayed past the rise of the power supplies. So you can't just tie it high to the power supply. So that's a good catch, because that would make all the boards basically not work. So that's a good thing to catch. Also for Tom, I'm going to write up a little description of what every connector does and what every jumper does, and maybe that'll help show you what I had in mind for the connectors that were extra, or the jumpers that were maybe not obvious what they do. Because yeah, it is kind of daunting to look at it and say, well, now what did he have in mind there? Because there's no explanation. Although I did put a couple of notes on the schematic. So I will do that when I get a few minutes to send that out to you, Tom. I just haven't had a chance to do it. I've been working mostly on the data engine, and of course, it always turns into more work than you think. So I think I've resigned myself to the figuring out the bank 5 and 6 problem for the memory, and I'm going to do what Altera recommends. It's always good to do what the manufacturer recommends instead of doing what you think is best, because usually what I think is best isn't really what's best. So, and of course, you know, I've asked them 3 times, well, what happens if I don't do it the way you recommend? And they won't answer it. So you're really better off doing what they say. And if you want it to work, which is going to be really important for it to work. So I'm now in the process of juggling the IO pins around to free up those extra pins and use the pins that I have to use on bank 5 now that have to be 1.5 volt IO. They're perfectly good for reading push buttons and driving LEDs with buffers and things like that, but they're not any good for high-speed stuff that has to be level translated to whatever level you want. So it's just a nuisance factor. And I did pretty much, I got the power supplies all completed. So in fact, I want to ask Tom to look at that when he gets a chance. I'll cut the pages out and send them to you and see what you think. And let's see, what else do I have? Oh, I guess as far as Mohammed's question on the market for amplifiers, I think it just depends on what your use cases are. So if you're just going to make a general purpose amp and expect people to use it, you're going to get, you know, I'm not sure what VHF and UHF users are, but you're not going to get that many. But if you were to, for instance, make it useful for a satellite base station, now all of a sudden there's a huge number of people that are interested in it. So you'll get a lot more interest in that case. So, and I guess you have to look at the particular band of interest, what, who's going to use that? What are they talking to? Are there repeaters on that band? Are there satellites on that band? What's the use case for your? And so when you get down to the end users, like users for repeaters, there's a lot of them. Builders of repeaters, there's not so many. Builders of satellites, not so many. But users of satellites, a lot. So that maybe give you an idea of what the market would be for those. And I think that covers everything for this week. So back to you, Dave.
Okay. Well, next on the list we have Dave Whitten, KD0EAG. Go ahead, Dave.
Hello. I guess I've been working on odds and ends. Jules and I have been looking at bearing the magnetometers vertically. That probably is precluded by the design that this project has gone with, but we're trying to see what the real best behavior we could get out of this. And so we've been experimenting with these garden augers that allow you to take an electric drill and drill holes in your garden and either take the existing boards and bury them vertically, or actually design a different board that has the magnetometer component sitting at right angles to the thing. This may be of no interest to this project, but we're just looking at what we were really interested in getting to the maximum potential of the sensor, and but things have moved ahead. There's one thing I asked Scotty that he didn't answer, but I'll ask him later, I guess. And otherwise, I can't say I've done much. I haven't heard much from any other people working on the magnetometer. Haven't gotten any feedback, so I don't know where things are. But I guess it's where it is. So that's it for me.
Well, fine. We'll see if anybody has other comments for you, Dave. Next on the list is David McGough, N1HAC. Go ahead.
Hello, everybody. Well, I have been working on the magnetometer, but I don't have it all together yet, and I do have questions about how it gets powered and some other addressing questions. As I mentioned last week, I've got an early version of the board. I have to patch the I2C pull-up resistors to something, presumably 3.3 volts, because they're on this board connected to ground, which doesn't work. And then some other questions where the 3.3, does that get generated on both boards or what? And where does the 5 volts come from? I'll look for answers to that. I'm not really quite sure why we're getting so upset about temperature drift, because generally when we're looking at aurora and such, you're looking at differences, not so much the absolute magnitudes. You know, we can have a discussion about what we really need for data out of it, because I don't think that plus we have the temperature sensor if we needed to compensate. One other thing I wanted to mention to Jim Seacon, welcome, and I'll point out that we at Dartmouth actually listen to that band all the time, but we're looking for auroras at 3 megahertz. And I'm wondering if there's anything our receivers could be doing to feed data that's coming from these other sources.
Did you say 3 megahertz?
I said 3 megahertz.
30 is where I'm interested.
Oh, you said 30.
30.
Okay. Well, we've also done a lot of rheometer work as well. And I do have rheometers that can be set up and whatnot. In fact, I just retrieved one of our 30 megahertz antennas for that. But I'd be interested in knowing if we can help contribute to that. Are you looking for all parts of the sky?
At this particular time, just the noisiest stars that are out there, and there appears to be a handful that the community at large uses. Just coming into this, I know Cassiope A is one of the major ones they use, and that's primarily watched from Northern Hemisphere. I don't know whether you can see it much from Southern Hemisphere.
Right.
But my interest for this project is ionospheric mid-latitudes, which is sort of defined, I would say, as maybe 20 degrees geomagnetic to 40 degrees geomagnetic latitudes, in that range. So, you know, places that are a little more accessible and easy to put instrumentation than, say, Barrow, Alaska, or places where you go to look at aurora and it really interesting stuff.
Yep. Well, you know, we're up in New Hampshire and certainly could install equipment in this area too.
Okay, you ready to go to the next fellow? Dave, are you done?
Yes.
Okay. Next on the list, we have Jay, WB8 SBI. Go ahead, Jay.
Okay. Good evening, everybody. I'm on audio only tonight. First opportunity to participate in this, but been following along casually for a while now. Nathaniel, this was a very good presentation you guys did this past weekend at the QSO Today thing. That was really cool. So otherwise, guys, I'm just a retired embedded software engineer having fun playing ham radio and FTA. Take care. Back to net control.
Well, welcome, Jay, and I hope to see you back here. So we're at the end of the list, so we're open for general discussion.
So Dave, did Elizabeth want to get in there? Yeah, do you have your audio working? No. Maybe you could call in on your cell phone and to the telephone number, and that might work.
Yeah, that's a good idea. That usually
She's done
solves
that a couple of
audio.
years.
Yep,
Couple
that's
of
been
times.
done.
Grab
Anyway,
a flashlight and send Morse code.
So I wanted to address Dave's questions. I haven't sent any answers out to the comments I got on the board yet. I will get to them all when I get around to it. I just haven't had the chance to do it. So I'm hoping it's not holding anyone up, because you seem to be going ahead and making progress anyway. I like your idea of ground augers and burying your boards in your garden. So you have a bunch of like gopher mounds with boards buried underneath them.
Yeah, yeah, that seems like they'd be stable and as long as nobody runs over the wire with a lawnmower.
Yeah,
I think
temperature stable too, because they're down below ground.
Yeah,
and
that's really...
I think that's what they did for the Themis education public outreach magnetometers too. I think they buried them.
That's where I got interested in it. I was reading, except I have the entire book about Themis or Themis, whatever it is, but I don't find. There's a diagram, or there's a photo I remember in something you sent me about burying these things, and it's not in that book. It must be in some of the education outreach stuff that I don't know what I'm sure I saved it, but
I can find it for you again, because there was a separate paper just on
Yeah.
like the Themis EPO, and I have it on this computer. I can get that to you.
Okay, I'd appreciate it, because I remember it clearly, but I'd like to look at it again, and I can't find it in my already pretty big volume of stuff on this project.
So as a quick question, are the X, Y, and Z magnetometer ranges all the same? So if you put the board flat or horizontal, all it's going to do is it's going to exchange one of your axes for another. It's not going to really affect the calibration or anything, right? Is that correct?
I believe so. Yeah,
That
I
is
believe
correct.
So. Yeah, so technically you can just do it numerically, I would think, but you know, I also thought it would be possible to mount it the way they intended, but it doesn't matter. It'll be, yeah, it seems like a good way to do it, but we were just going to try it.
There might be an issue of labeling X, Y, and Z differently coming out of the software. So, but that should be an easy fix.
That should be trivial to fix.
So then are you taking the board and like mounting it inside a PVC pipe and sliding the pipe down in the hole? Is that the way you're doing it?
Well, so far, yeah, that's what we're fooling with. Frankly, I'm not absolutely sure all of what Jules might be up to. He was using a longer pipe than I thought necessary. I think, you know, something this long, you know, fits pretty well, but there might be other, you know, he was using a 2-foot pipe, but maybe that's just because that's what he had. But
is he using the SparkFun board or one of your boards?
I can't tell, you know, he said he's going to send me some pictures, but I think he's been busy. He's done a lot of different things, and so I'll have to see. There are some problems with the boards that I made, but the last batch but they don't seem to, well, except for the ones that I have, they don't seem to make them not work. My big problem is, are those pull-ups or pull-downs on the address lines for the MC9808? Because the way you have them marked, you're doing them opposite of what the little Adafruit breakout board does. It has a 10K to ground, I believe, on each of those address lines.
Yeah, and the way I read the spec is you can, if they're just address lines, you can pull them up or you can pull them down, and then the address matches whichever direction you pull them. So you pull them all up, then those bits will be 111. If you pull them all down, they'd be 000 or whatever combination.
Where should the resistors be?
Well, are you talking about the address lines or the
Yeah.
I2C lines?
The address lines. And they
You
can
can do it
be-
any way you want, or you can just pull them up, pull them down with no resistor.
Because they seem to work pretty well even without any resistors. Or
You can not use a resistor if you want. Normally, I
Yeah,
use a resistor to protect the input, or if you want to tie the thing low later and not have to take the resistor off.
I
If
see
you turn it to ground, then you've got to lift the pin to take it off to raise it.
I
So
see.
Yeah, but it does have to be asserted to one or the other. You can't just leave it floating.
you cannot
I
float
see.
them. So they can either be
I
tied
see.
directly to ground or power, or through a resistor to ground or power.
Well, this is
Yeah,
my
so how you
naivete.
done it with 100K to ground, and then you pull it high if you want to change the address, that's not a bad way to do it, because that's
One of the
minimal
tricky-
current when you have it asserted the other way.
One of the tricky ways I did it is on the Raspberry Pi, there's 6 ground pins on the header. And so what I did is I connected 5 of them up to the actual power ground. And then the 6th one, which is ground in the Pi, I hook it up to one of the address lines with a pull-up on it. And so when you plug the board on the Raspberry Pi, then it grounds that pin, and then you get a low for the address. If you don't plug it into the Raspberry Pi, then the pull-up on the board pulls it up high, and you get a 1 for that pin. So you don't need a jumper. So the remote one is obviously not going to be plugged into a Pi. The local one is going to be plugged into a Pi. So then the only other case is, well, what happens if I want to run it local and not plug it into a Pi? Like if we want to use those small connectors that you found, Dave, the
little JST
little JST connectors. Well, then, so I put an optional jumper in parallel with it. So if you want to jumper it without the Raspberry Pi, you can do that.
I
So
see.
I know that confuses everybody, but it's because it covers all these use cases that we're probably not going to do. But it's basically for free on the board if you don't put a part there.
I see. There's one of the pictures.
Is that what you wanted?
Well, that's a good one. I remember. Yeah, I remember that one. This is probably the right thing.
I can send you this.
I'd appreciate that.
Okay.
Yeah, another person that I know buries magnetometers is Mark Lassard at UNH. He generally does search coil, but he buries his magnetometers.
It's as much for insulation and keeping them, positioned in, stable way as anything. It's just we were just trying different options. I'm making some little boards also with a lot more test points on them, places to pull off, so I can do diagnostics and things better. Probably of no concern to the project.
Dave Witten, can you explain to me quickly how this system is powered, where the 5 volts comes from? And it looks like you've got a 3.3 volt regulator on both boards, but it's also being fed from the Pi. Is that correct?
The 3.3 volt regulator should not be used if the external 5 volts isn't applied. That should be coming potentially from the Pi or any other source, but that's on the local end of the system. And the 5 volts is used for as is for the signaling between the two I2C extender chips between the two boards. But it is on the remote one. I believe it was intended to be regulated down to 3.3 also to power the remote board.
Right.
Okay. Is that answering your question?
But where does the 5 volt come from?
On the board that you have, it's a there's a jumper marked external 5 volt.
Right.
And it goes to the intention is, I think I sent you a little SparkFun Raspberry Pi GPIO deal that has both the JST-SH, what they call the quick connector, and it also has a 5-volt.
Okay, so that gets connected there too.
Yeah, that's the place it's coming from.
That's what I wasn't clear on. And that 5 volts gets routed through the cable out to the remote, and then the remote regulates it down for the 3.3 volt stuff.
It's actually used in two ways. One is just routed as power to the remote. Also, it's used as signaling between the two PCA 96.
Yeah, I know they're running on the 5 volts as well.
Yeah. So if that works right.
Okay, so I saw one picture where both boards had the 3.3 volt regulator inserted, and you don't want it on the one that's at the Raspberry Pi, correct?
Well, the idea was that it was the same board either place, and that it was an inexpensive enough chip to put on there. But yes, you can leave it off, and there may even be it may even be better to leave it off.
Is there a place to disconnect the Raspberry Pi's 3.3 coming in?
Well, no, it's coming in with the I2C. Because that's the signaling between the Raspberry Pi and the local side of everything.
Yeah.
So
I'll figure that out.
You need 3.3 from the Raspberry Pi.
Right. Well, you can use that local regulator and just not get the power from the Raspberry Pi, correct?
Conceivably is on the local end, but I was concerned about offsets between the I2C and the 5, and the powered down 5, regulated down. They might not regulate precisely, and that would be a potential source anyway of this was something we at least I worried about, whether maybe pointlessly, but I'm not as you may have noticed, I'm not the consummate expert on this subject.
Okay, well, I'll work with that and see what I think on that. And the one last thing, I've got Rev 0010 boards. Is there a schematic for that online?
And what schematic do you have? Do you have the 11?
Yeah, 11 is what you're supplying.
Yeah.
But the board itself is a 10.
I'm afraid.
So I need to be sure of the differences between them.
Okay, they're almost identical. I may be able to give you one. I think I overwrote it.
Okay. Well, I'm having to reverse engineer it a bit. Because you do the addressing differently, and you have some. Oh, the I2C pull-ups are actually pull-downs on that board. So I have to patch that.
I2C. Okay. Well,
those 4.7K resistors are going to ground, not to VDDA.
I didn't change that between versions, I don't believe.
That's not where they're going.
Okay. I'm not saying they were right to begin with, but
okay.
Anyhow.
Well, I'm just about ready to power it up, and I'll probably get some direct questions to you. Thanks.
Yeah. Okay, great.
So, Nathaniel, do you think it would be worthwhile going over the Raspberry Pi hat schematic, or should we just leave that to the people who want to?
I think you can go over it.
I could do it quick here for a few minutes. Maybe that can answer some of Tom's questions as well as Dave's questions. So if I can...
You should be able to share your screen.
Okay, I think this is the right one.
Yeah, I've got an immediate question for you, Scotty, there, and I think I know the answer, but you have a header there for the magnetometer board, but you also have the magnetometer chip itself. Are we able to populated either way.
Right. The trick to reading these schematics is if you see anything that says build equals DNI, that means do not install. So we just put the chip and the magnets and the coils on there as DNIs in case we want to build a board that has everything built on it. So the question, this was, I did this before Dave got the question answered from the manufacturer that they're willing to sell us, hundreds of these boards. Because if you go on the website, you can only buy 10 at a time. So you're going to have to go in and talk to somebody if you want more than 10, it looks like.
Right.
So anyway, so what I opted to do is right underneath where the board would go, where it would plug in, we copied the exact positions for the IC and the three coils.
Yep.
So that if you don't want to plug it in, then you can plug the magnetometer on there. I mean, you can leave the magnetometer off. But of course, then the downside is you get a magnetometer on both ends because you can't unplug it because it's soldered down.
Yep.
So
I've done that too, alternate footprint type of thing.
Yeah. So anyway, if you look at the schematic, maybe one of the most confusing things is if you look at can everybody see the screen? That's being shared, right?
Yes.
So if you look at this ground pin right up here, pin 6, I guess it is. I can't see very well. So it's pin 6. Well, that's grounded on the Raspberry Pi. On our board, it's pulled up to 3.3. Now this, I do it a little bit differently than Dave did it. I regulate off the 5 volts. And okay, let me start out saying this right here this is the PROM that every Raspberry Pi hat is supposed to have to make an official Raspberry Pi hat. So it's just copied directly off of the Raspberry Pi spec. It's a 30-cent PROM with a write enable strap that allows you to initialize it. Then you pull the strap off, and it's supposed to give an ID for the board serially to this I2C port right here.
Is that the actual part number, Scotty? Without a bomb, I was wondering about.
I can give you the bomb, but that is the actual part number. I try to put the full part number on the schematic.
Okay.
So less confusing.
Wasn't sure sometimes.
Yeah, and so that's what the purpose of this is. So if we want to make a low-cost version, which I mean, save 30 cents for this part, 1/10 of a cent for each resistor, and 10 cents for the strap. Not worth bothering to have a separate variety just to save 50 cents. So at any rate, that's what that's for. And now you'll notice that the regulator down here takes 5 volts from the Raspberry Pi up here. And I do not take any 3.3 volt power for the Raspberry Pi except to run this PROM here. So both ends of the board are run off their local 3.3 volt regulator. One of them directly off the Pi, or from one of these connectors down here if you want to feed power directly in. Or on the far end, you'd get it from the Cat5 cable, and then it would go into the regulator, and you'd use the 3 volts from the regulator only. So you'll notice that other than this regulator here, everything is run off the Pi 5 volts. All the 3.3 volts comes off of this regulator. So anything out here in the schematic is going to come off this 3.3 volts right here from the regulator.
Okay, yeah, so I know Dave was a little concerned about that, but I wouldn't worry about it as long as you have a reasonably accurate 3.3. They're going to be within a diode drop of one another, and there won't be any.
Yeah, and the regulator should be at this kind of loads within like 3% or less, so it shouldn't make any difference. Anyway, so what we do is we pull up this ground pin, so when there's nothing plugged in here, in other words, if you're getting your power from the Cat5 cable, or if you're getting it from one of these optional connectors down here, which we'll cover in a minute, then you have nothing plugged in here. So this is unused, and this pull up here pulls up an empty pin. Okay, so then that makes this high, this line. Okay, so you can either plug the Raspberry Pi in to lower this line to a 0, or you can jumper this optional header here to make the line 0. Either way works, but we're planning to leave this header off. See, it says DNI right here. So we'll leave this header off. So the idea is if it's a local guy, you plug it into the Pi, you get this line 0. And this line, by the way, sorry for the confusion here, but if you follow it down, it's called local N. Okay, so local N means it's active low. So if this is a local board plugged into a Pi, this line is low, and it feeds the A0 line of both this is the onboard magnetometer, and this is the SA0 line of the plug-in magnetometer, and then the SA0 line of the temperature sensor. So what it does is it automatically shifts the address +1 whenever you unplug it from the Raspberry Pi. So if you run it remote, and I put the addresses here, the I2C addresses here. So if it's local, it's going to be 18, but as soon as you unplug it and raise that line, you're going to get 19 for the address. Same guy up here. Sorry,
I think that's brilliant, Scotty.
Oh, thanks. It just kind of fell out. It's like, how can I make this so I don't have all these jumpers? Well, there's an automatic jumper for you. And then we program these two the same. The idea is you're never going to have the parts mounted on the board and plug one in. That's ridiculous. So you're going to use, these two are either or. And we're going to start out with the headers here and plug in boards and not install any of this stuff down here. This is just going to be traces on the board. Okay, and then to satisfy the people who want to use this locally with either flying leads or without a Raspberry Pi, or maybe you've got another single board computer that has I2C that doesn't have this pin out, this connector on it. So we added some connectors down here, and let's see if I could remember all of what I did. These guys here have 3.3 volt off the quick connectors, and these quick connectors are made to pass the data through. So you can create a daisy chain of connectors. So you have an in and an out, if you will, and the board just hangs off of the chain, off the I2C chain, since it's multi-drop. The external 5 volts comes in here, and this is another connector that Dave found. I think, is it Dave? Is this the one that SparkFun uses?
I think that's just a.
Oh, you're right. This is just a pair of pins.
Yeah, it was a pair of pins the way I had it. I never could find the one I wanted. But you can solder the right one on, the one that has a little keying to make sure you don't plug it in backwards.
Yeah, this one has, you can see it says vert ramp. This is a locking connector that is polarized.
I see. Okay. I just couldn't find it.
Yeah.
And
so this is just a 2-pin 10th-inch center. You can plug you can solder a regular header in there if you want, if you're so conscientious that you never ever plug one in backwards. Unlike me, who will smoke every board I have if I don't have polarity on it.
I have done it already.
Yeah. So anyway, you can feed external 5 volts in here, and then you could hook up either a SparkFun I2C port into one of these guys, or if you have a Grove port on whatever board you have, you can plug it in here. They all are in parallel with the I2C. So these are optional. We're not going to put them on the board, but they're there in case you want to solder one on, and if you have the skill to do that. These, like as Dave pointed out, these quick ones are pretty difficult to solder. And since these are vertical ones, so you can do it if you do them in the right order. If you do them in the wrong order, then the first one you put on is going to block the second one. So you have to be a little clever about how you do it. And
the
then
use case for some of that is if you want some other sensor, say local to the thing, like a pressure sensor, for instance, it's easy to plug one in to one of those things, and it'll appear on the same bus. I don't know why you'd want a pressure sensor, but they're available, and those things make it easy.
And the interesting thing is you could put a pressure sensor to measure barometric pressure out at your remote if you wanted, because you could plug it right on here.
Right.
And you get power and the I2C, and it just hangs off the bus. So anyway, for future expansion, and in addition, a PMOD connector. So in case you want to plug this into a PMOD adapter, which we're not going to do anymore, but in case you did, it's there. These are all going to be unpopulated. Let's see what else do I have that was interesting. Hopefully I used the same pinout that you did, Dave. I stole one of the power pins, and we did, I think Jules did this. We did the analysis on how much power is actually being drawn. And by increasing the capacitance, as you can see down here, we increased this to 22 microfarad. I think it was smaller before. We could ride out some of the transients on the 9615, 9515. Anyway, on this, the I2C part. And the biggest power hog here is the terminators anyway, these guys right here. And what I wanted to do is I wanted to be able to do something that the existing board did not do, and that was to use the, see, where is it? It's the D-Ready line out of the part, which comes out of the part here, and it also comes out of the plug-in module here. So what I did is I stole one of the power lines down here. So you've got clock and data. If I can, yeah, so data, 5 volts, and here is the trig. It's called trigger. And the idea is you program the part to use the D-Ready line to give you an interrupt when you see a transition of so many nanoteslas. So we currently don't use that, but it might be useful in the future. I don't know if this is going to work because nobody's tested it, but if it doesn't work, then you just leave the parts off and you say, oops, and we don't use it. And basically we have the same functionality we have now. But the idea is that on the local board, if you have just a local board and you plug this guy on here, then you can use this inverter, even though it looks like it's not an inverter, it's a Schmidt trigger input, and it runs an interrupt back to the Raspberry Pi. And in the local case, in the remote case, it comes in on this LD trigger line, and it comes in and goes through this non-inverter, because on the other board, remember, there's already going to be an inverter. So you're going to invert it twice. This actually is a non-inverter. The gate inverts it and the FET inverts it. So a 1 here produces a 1 here, a 0 produces 0. But on the other end, you got an inverter that drives the line coming out here, and that gets driven by this FET right here when you put the jumper on here. So you still have to have a local remote jumper, and I have a little cheat sheet right here. So you jumper pins 1 and 2 for local. Okay, so if there's a local board, it's got to read the remote. So it takes the remote input here and feeds it to this IRQ here. If you jumper 2 to 3 for remote, then this becomes the remote output, and it goes down here. And oh, incidentally, it goes back here and drives this pin right here, but it's remote, so there's no Raspberry Pi in the socket. So it just drives a hanging line that just does nothing. But the main thing is that this FET here drives the external wire that goes back and then comes in, oddly enough, on the same wire. But now remember, that board's strapped differently to take this path right here. And this FET now on the local board will be just hanging, doing nothing. So this is really the only, I believe, the only jumper you have to change on the local or remote side. Or if you don't want to use this functionality, just leave the thing off. Just leave the jumper off.
Okay, Scotty, that helps explain a lot of things. I was trying to figure out why one grounded a pull-up resistor.
Yeah.
That sort of explains it. I think a table would be helpful. The table saying, what are the different ways that this board can be used? Standalone, local.
Well, so we have
remote.
standalone, local, we have the 3 ways, and then we'd explain how to jumper it each way. Is that the idea?
Well, and then what are all the considerations for each of the application scenarios? So for example, when it's standalone, you know, A, what do you jumper? B, how do you power it? C, what hooks up to collect the data from it? When it's local, you know, those things. When it's remote, those things. I think that table would add a lot of clarity.
Okay. You want to put the table on the schematic here, or is
or make a page 2 of the schematic and put the table on it, or put it somewhere. But you know, okay. I think folks would find that table to help guide them through using the module.
Yeah, because I sort of have it here spread out across several jumpers, but it's kind of hard to understand. I agree.
Right, and then you know, Dave was asking the question, you know, where does power come from? And the answer is, well, it depends on how you're using the module. That kind of information, I think, would be very valuable.
Okay. I was kind of thinking that that should be in the ICD document that's not written yet.
Okay,
but
well,
does that make sense, or is it better to have it on here?
Yeah, in my view, I'd put it on page 2 of the schematic, just because that way you're pretty sure someone who's trying to figure out what's going on is going to find it.
Okay.
Yeah,
Well, I
of
actually
course
have,
it wants to be in the ICD, but it would be helpful to have it on the schematic as well.
I actually have a layout here, but I'm going to rip this out because the layout that we ended up with doesn't even resemble this. So this is what I gave to the CAD guy to start with. So it's interesting to look at what we got versus what we asked for, because he moved some things around to make things work better than I did. And all I wanted to do with this drawing is to make sure all the parts fit on the board. Of course, he has a lot of trouble with me with that because I can fit all the parts on the board, but that doesn't mean you can route to them. So,
Well, one thing I'll point out, if you have the magnetometer on the board, you have to orient it to north properly.
Yep, and I have this right here like this. This is kind of like an indicator because this is actually printed on the board, and also the baseboard is heavily marked for pin 1 here. So to make sure you plug it in the right way, because physically there's no limitation. I mean, you can plug it in backwards. So there's no polarity protection other than markings on the board.
Yeah.
And I don't think the magnetometer is really marked that well as far as indicating what pin 1 is. So I was a little concerned. So I put this north on here because this matches exactly what's printed on the silk screen on the magnetometer board.
Yeah, that's very clear on the board, which direction they're calling north, so that works.
And then just a second here, I'll show you what we ended up with. Let's see. So this is the final assembly drawing. It's not very clear actually, so let me find a better one that shows the parts. Okay, that's the back side. Not what I wanted. I'm very new to computers, you know. And that's not going to help. This is the layer stack up and the drill diagram. So I guess we are pretty much stuck back here. So you can see the RJ45 is over here. Again, this is not going to be there. This connector here, these 4 connectors right here are the 5-volt and the Quicks and the Grove. They're going to be all absent. And you know, you guys know how big a Grove connector is. I mean, it's only like that big. Well, look how big it looks sitting on here. It looks huge to me because this whole
small.
The location of the N symbol there, isn't that on the wrong end of the board?
This right here?
Yeah.
No, because the pin 1's right here.
Right.
And you plug it in and the N is actually right here on the magnetometer board.
But, okay, but which way is the N pointing?
Pointing to the left.
Okay, yeah. I'm going to have to go look at the board again.
Hey, if that's wrong, let's fix that now. Because
no, that is correct. That is correct. The P&I board's a little. It might be sensible to have the N at the, you know, well, that's where it is on the board, yeah. So it would match up.
So. Put it in the center, so we put it here. And also, if we were to overlay the P&I board on top of here, you'd find out that the coils and the part are dead over the top of each other. Because that's what I told the CAD guy to do. I said, if I unplug this board and use these parts, I want them to look exactly the same. I want them laid out exactly the same. I want them polarized exactly the same. I want them in exactly the same spot so that it technically will look no different than if we plug the board in here.
Yep, and actually looking at the breakout board, there actually is a pretty good pin 1 mark on it as well.
Okay. So see,
it's got a white corner marked off to it.
But an arrow and a 1 both, so that maybe helped a little bit. And then the right enable jumper is here. The address jumper is here. The local remote jumper is here. And then, of course, we have the shield connector here that, so you can connect the shield on one end of the cable, but not on the other. And we did put a mounting hole here, although this is going to land right in the middle of the Raspberry Pi. So my guess is this is so small, we're going to end up with just the 2 Raspberry Pi standoffs holding the thing in. And it'll just cantilever out. I mean, it's only like an 1.25 inches, 1.5 inches, something like that wide.
But at the far end, you might find that hole useful.
This one here?
Yeah, the third hole.
Oh, yes, at the far end, you're right, because it won't be over a pi, right?
Right. And it might, having 3 legs is always a little better.
So that answers the questions. I have to address the enable pin. I think putting the capacitor and the diode on there is a good thing to do because it's needed.
Scotty, can I interrupt just for a
Sure.
second? We are at 1 hour and those with time constraints, and I have a time constraint tonight, so I'm going to be out of here. Just thought I'd say that.
Okay. Well, any other quick questions before? Because I'm finished. So, unless someone has a question.
What is the full the extent? The dimension. Do you have a dimensional mark?
Yes.
Yeah, like that. That's what I want. Is there any way? Can you? Well, it's 37 millimeters. That's the most important thing. 37 by 65.
And this cutout here is for one of the MIPI connectors, the video connectors on the Pi flex cable. There's another MIPI connector right down here, but we made the board short enough so that it doesn't interfere with it. It's down here.
I'm really thinking, if I want to put it in a piece of PVC pipe, what diameter do I need to use?
Okay.
Because I'm thinking of 3D printing some little things to hold it in place.
So you need
inside
maybe
it.
a 1.5 inch ID pipe?
Probably 1.5. This is 1.25 I was looking at before, but 1.5 is probably more likely.
I don't remember. Is PVC measured by ID or by OD?
I think it's usually ID.
But ID.
I've sanded all
So
the
this is
markings
just
off what
shy
I have.
of 1.5.
So hopefully you can mash some, put some hot glue on it and jam it in there and it'll stay.
Yeah, I was actually going to
Although,
make some
and that is the thing, that the RJ45 is pretty tall and it is not, it is near the edge, but it's not right on the edge. So I don't know if this would fit in a 1.5 inch pipe with that height.
I think you're more likely going to want to put it in 2 inch and have some padding around it.
Yeah. Or you might be pounding it in.
Yeah, well, you don't want it to move as you're doing whatever you do, burying it or mounting it or whatever. You don't want the electronics inside to change their orientation.
Yeah. So you want it rigid, however you mount it.
You want it, stable. And when you're setting it up and over time. So just thinking of the, just little realities.
Yeah. So that's the hat. Thanks to everyone for taking a look, and especially that catch on the enable. That would be bad to have missed that.
Just Scotty, what size components are you using on that? How big a grain of sand are they?
0402s.
Oh, okay.
The components are all 0402s, except see there's some 0603 capacitors. Now a lot of times you can buy the higher value caps as 0402s, but they get really expensive. So
right. Yeah.
I choose to use it 0603, or in the case where you need like the PTC, you got to have the area for the power dissipation. So, and the ferrite beads are the same way. You can't get much inductance without volume. So they're kind of picked where they're needed. And I would pick 0402s given no other criteria. And besides that, 0402 is the smallest size I can solder by hand.
Well, I was going to say.
Better you than me, yeah.
Yeah, our CM wanted to try.
I prefer not to do 0402s, but.
Well, our CM wanted us to try 01005s.
Oh.
And I'm going like, are you kidding me? I can't even see those. And what he wanted was us to be the guinea pig for his super small SMT line.
Around here, we have a name for those, just like the bug. They're no-see-ums.
No
Yeah,
seams.
no seams. Yeah, you have to keep them in salt shakers and just kind of shake them onto the board when you're assembling.
And if you drop one or it flies off the board, forget it.
Oh,
Get
forget
another
it.
one out.
Yeah.
So hopefully this will address all the problems. That was the question I wanted to ask. There was some talk about addressing. And so I put the addresses here. So what's going to happen is this guy is soldered down. The temperature sensor is soldered down. So there's going to be two of them in the system because you're going to have one on the local end and one on the remote end. But they're going to be different addresses, 18 and 19. And then the same token, if you wanted to, I don't know why anybody would want to do this, but you could leave the P&I part on the local end because I shift the address also from 22 to 23 on the local end, whether you have one on the local end or not. So, I mean, I can't see that's worth anything, but you could have two magnetometers in the system and you could measure the difference between at your Raspberry Pi and out in the backyard.
Seems
because I did
much.
shift the addresses, so you could do that if you wanted.
Yeah,
and then if we ever build a board,
oh, so neither of them are 20 though.
Neither of them are 20. Now, if that's a problem, I could make them 20 and 21.
No, it's just that the default's 20. That's.
I kind of wanted to make it different, so now you can tell the difference between your board and this board. Software can tell.
Oh yeah, there won't be any trouble there.
Yeah, but there might be trouble, talking to it at all if you don't look for address 22 or 23.
Yeah.
So is it easy to change the address to talk to the board?
Oh yeah, trivial.
Okay.
There's a command line option. If it's, or I can set it, make it, and my software's just for testing anyway. Nobody's going to use my software.
I don't agree with that. I looked at your software. It looks awesome, Dave.
Well,
I was expecting some hack job like I would do. It looks more professional than I could ever do.
Well, I tried to build in a lot of options, but but anyway, you're gonna, it's there if anybody has a reason to use it. But,
well, won't we be using it for the testing? I mean, that's
what it's for, is testing. Yeah, that's the idea. That ought to work pretty well there. It makes a lot more sense now that we've done it this way with using the GPIO bus as the direct plug in situation. I mean,
yeah, and that's the thing, is like everything on the Tangerine SDR and this personal space weather station is like, why did we do that to start with? Well, we learned. We did things and we learned.
Yeah. Well, one thing to keep in mind about all of this is that as far for the softwares, every single one of these, even though they all work the same, more or less, talking to the I2C, all the different boards, the Odroid, the Raspberry Pi, the NVIDIA's, the I don't know, there's a million of them, and they have mapped the I2C buses differently. So the actual bus number you want to talk to, you have to set it right for the board in the software. So that's something's gonna.
Oh, so not only the address, but the bus that can.
The bus,
okay.
Because they usually have at least two I2C buses. But now you're not planning to do any probing on the I2. I got the idea for a while you were thinking about probing the I2C bus to look for the prom or something, and try to guess where things were. And I've been kind of worried because probing the I2C buses on these can lock them up.
Well, so so that would be like, for instance, if you wanted to try and figure out what kind of board is out there, you would go to address 20, and if it responded, you would know it would be your board. What happens if you go to address 20 on this board and there's no address 20? What is that what you're talking about?
Well, going that far is probably okay, but just trying to scan the addresses, certainly especially if you don't know which bus you're on the on different on different single board computers. If you try to scan like the I2C0 or 1 very often, a lot of that's used internally, and it's really easy to upset the CPU and put it in kind of a
because you might talk to some piece of equipment that's on the internal bus somewhere and not your piece of equipment.
Yeah, and some of them are SM bus, some of them are old-fashioned old I2C, some of them are different things. Some of them are voodoo, and so anyway, it's just good to know which. I wouldn't try to get too clever about identifying, having it run on every single board computer without even telling it what it's doing, the software.
But I tried to use the same I2C port that you used, the pins 3 and 5 up here.
Yeah, the port's fine. Yeah, the port's fine, but all of this is smoke and mirrors at the single board computer level. These are the single board computer, the operating system has all of these have the device tree that is compiled on each of the boards. Some of them you have to enable the I2C, and they all match internal pin numbers differently. I've got a Raspberry Pi, a PM3, one of the modular boards, that really breaks out every single one of the internal pins. And there's I don't know how many there are. Looks like there's 100 or 100, more than 100. And the Raspberry Pi doesn't break them all out. But they get mapped differently from board to board. Don't worry about that. I was just afraid that maybe from the FPGA, you might be thinking of scanning the buses to see which one to use, and that may not work.
Okay.
May not be advisable.
I've got one pet request that I always ask, and at least have a ground test point on there that you can connect a scope or a voltmeter to. I'm always searching for a way that I can connect to a ground and not short something out. Even if you don't put other test points on, I put test points all over the place. But
yeah, and normally I do that too, but this board is so small.
Yeah, but at least something you can connect a scope probe ground to would be helpful.
Connect the probe to the shield ground, because there's a ground pin there. But
that's true.
Yeah, that might be the easy place.
The jumper too. There's a pin that's grounded there. But putting test points on the back doesn't really do much good for the Raspberry Pi mounted one, because it's mounted right over the top of the Raspberry Pi. So
I'm not talking on the back. I'm just something on the front side that's a loop or just a pin.
Yeah, and here's another pin too on the right.
Grab on.
But like you said, if you clip onto there, you may end up shorting this.
Right.
So, and in this case, that wouldn't really make much difference. But probably better to have just a single pin somewhere, single pad that you can hook a wire to if you want. Or
yep, that would work.
Okay. Good advice. We'll make the mods.
Very good.
Scotty, if we're done with that, I've got a question for you. A software logic thing. I came up with an edge case I wanted to ask you about.
Okay.
Let's say, all right, we when we're working with the data engine, we're going to send it a channel configuration which tells it's okay. Here is the, in this channel, here are the sub-channels. Here is the center frequency of each of the sub-channels in this channel, and then we'll give it a command to start collecting data on that
Well,
channel.
you're talking about establishing streams, right?
Yeah, yeah.
So you're going to give it the parameters for the stream data, and then you're going to say go.
Yeah, so now we've given it the command to start collecting data, and it starts happily doing that. Now, the edge case I came up with is not something that I would intentionally do, but this might happen somewhere. So I just want to know what you would think would be the realistic thing to do. Let's say that we're busily collecting data, and then to the data engine comes a new configuration block for that channel. Now, there's a couple of options. You could knack it, say, well, you can't change channel configuration while it's collecting data. Another option is you could automatically stop data acquisition, change the channel settings, and then restart it. Or another option would be you could just say, okay, here I'll stop the data acquisition, and I'll change the channel to the new settings, and I'll wait for another start command. So
I think that's a better solution, because that if there's any housekeeping that I'm going to have to do inside the FPGA, that will make sure that it's definitively done, as opposed to just having me decide when it's going to stop and me decide when it's going to start asynchronously. I'm putting it back on the originator to say, okay, you don't stop, I'm not changing it. So once you say start, then you can't really modify the stream. You have to stop it first. That's not hard, is it? That
no,
seems like the best.
No. It's a single command. It's a stop XC.
So if you said change while it's running, you get a knack.
That's one option. That's one way to do it. Absolutely.
I mean, doesn't really matter to me. It just seems that's the cleanest way. Because what's going to happen if I have to do multiple housekeeping steps, then if we're going to be running while I'm doing these multiple housekeeping steps, you might get some weird formatting that you don't expect.
Yeah.
Whereas if you stop, then it's stopped, and then everything can. Thanks.
Yeah, to stop it first, I just want to know how far back the chain of things to do it. So I'll have to enforce this at the at the user level, at the user interface level, that if the user tries to change the data engine configuration while data acquisition is going on, I just block them from being able to do that.
Yeah.
So you can't.
Because the commands
before you change the configuration of the channels.
Yeah, because the commands that change the configuration are on the same channel that the start and stop command would be anyway. Because those commands aren't going to go over the data channel, because that's streaming. So there's going to be a channel associated with that stream.
The configuration channel is where the commands are passed.
Yeah.
You can control each channel individually.
So I think that's reasonable to say stop the channel first.
Yeah, okay. Well, I just wanted to get your viewpoint on that. So, but that kind of settles it. It's a
Okay.
good way to go. That's all I had.
Okay. So we talked out. I am.
That's all for me.
I think I'm good for the night.
Yeah, you guys in the Eastern time zone, it gets kind of late, doesn't it?
Oh my gosh, I'm beat.
Yep.
I want to. I'm hoping we can get MD Muhammad Maktoumi involved some more somehow. He has, as you could tell from when he joined us a little earlier, he has like a bit of a different interest than I do, but he's very interested in microwave engineering. So it'd be nice to get him involved in ham radio somehow.
Yeah.
Here at the University of Scranton, because then it'd be really good to have two professors that are involved in ham radio. So.
Well, there's a conference that he will definitely want to look at called MUD, Microwave Update.
Yeah.
That might be more along his alley, although I think at DCC we're still interested.
Well, that's what I told him. I said, he's like, how do I get involved? And I said, well, I think one of the best ways to get involved, I think to show up here. Of course, we didn't really have a lot of time to chat with him tonight. We could, spend a little more time later. But I also said, if you put together a presentation for DCC, that'll give people a chance to kind of see what you're doing and what your interests are, and that'll serve as a starting, like a talking point or a way to start a discussion.
Nathaniel, did he say he works at 3 gigahertz?
I think so. I can't remember.
That's what I heard. Like he was talking about 2 to 4 gigahertz.
Yeah.
S band and L band, right?
I heard 1.1 to 1.3. So.
Yeah.
Okay, I wasn't hearing gigahertz very well.
Well, he said L band
that well today. Just wondering because they stole a bit of our 3 gigahertz band today.
Oh, they did.
For 5G, they took a bit of the ham band away.
Oh no.
Or they're saying they're going to.
Which one?
Well, weren't they talking about taking 5 gigahertz away?
Well, this is 3.5 gig that I saw.
Oh, okay.
A quarter of our band taken away for 5G. Of course, my thing with 5G is how the hell are they going to make an antenna respond to all of these different frequencies that they're grabbing?
Well, I don't think they do. I thought when I heard Tom Rappaport talk about it at the RCA symposium like 2 years ago, I thought it sounded more like 5G was one umbrella term to cover many different protocols and like specifications, and not.
Yeah, but that means not every phone is going to talk to every tower.
On the same, I think that's true. Like I think
you're going to have to choose.
Well, besides that, 5G causes coronavirus.
only
Right.
if you have the little antenna in your mask.
Right.
So the aluminum
only at very high power.
Yeah.
And the vaccination they're working on, they're going to inject a little 5G receiver right into your arm.
That's
I've
right.
heard people say that the
They'll
vaccine's
track
going to
you.
have a microchip in it, so look out.
Yep.
But I guess I'm not I know very little about 5G, but it sounds like there's like an urban, like 5G for an urban environment, and that's going to have one set of specifications, and there's like 5G for a rural environment, and that has a different set of specifications. So
Well, I don't think there's any such thing as rural 5G, frankly. If they're talking about it, it's a red herring.
Well,
no, like it's a different set of protocols. Like it's not using the same frequencies. It doesn't have objectives.
Which also says, if that's true, you have to use a different phone.
No, if there's a way to make the phone more complicated, they will do it.
I'm just telling you what I've heard.
Yeah,
like, this is.
It doesn't have to follow physics.
Well, have you heard when the physics guys met with the government guys, the regulatory guys, and the physics guys are saying, well, it's the laws of physics don't allow us to do this, and the federal guy says, well, that's why we're here. Help with the laws. Totally not getting it at all.
Boy.
Yeah, we've had some experience with that in Alabama where people think you can change the laws of physics by legislating. Like at one point, they actually passed a law that for simplicity, from now on, we're going to define pi as exactly 3.
Yeah, right. Yeah, that sounds like that makes things so much simpler, won't it?
They did things like that with some regularity when I lived there.
All right, night all. I'm running down too. And Nathaniel, you got to get to bed before you drop over.
Yeah, I know.
Yeah, it's a bit late over here.
Night all.
Good night.
Bye, everybody.
73.
Hey, Nathaniel, can you leave it up for a minute for Dan and I to chat?
Oh yeah, sure. You can. I'll stop the recording if that's okay.